If your game is stuttering, lagging, or just not running as smoothly as you know it should, you are not alone. Millions of gamers every single day sit down at their PC, fire up their favorite title, and watch their FPS tank at the worst possible moments. Whether you are pushing through a competitive ranked match, grinding through an open-world RPG, or just trying to get a smooth cinematic experience, low FPS can absolutely ruin everything. Here's the good news. In most cases, you do not need to upgrade your hardware. You do not need to buy a new GPU or add more RAM. What you actually need is to fix the settings, both inside your game and deep in your Windows operating system, that are silently throttling your performance without you even knowing it. Today, we are going through 10 settings that will instantly boost your FPS. These are not vague tips like lower your graphics. These are specific, actionable changes you can make right now that have a real and measurable impact on your frame rate. We are talking optimizations that professional gamers, streamers, and PC enthusiasts use every single day to squeeze every last frame out of their machines. So whether you are rocking a high-end rig or a budget build, these settings apply to you. Let us get into it. Setting 1. Enable game mode in Windows. Let us start with something that is built right into Windows and that most people have never even looked at. Windows Game Mode is a feature designed specifically to prioritize your game above all other running processes. When it is enabled, Windows tells itself, right now the most important thing happening on this PC is this game. Everything else, background apps, update checks, notifications, takes a back seat. To enable game mode, press the Windows key, type Game Mode Settings, and open it. You will see a simple toggle. Make sure it is turned on. Now, here's what game mode actually does under the hood. It prevents Windows Update from performing driver installations or delivering restart notifications while you are in a session. It also dedicates more CPU and GPU resources to your game process and reduces background activity from system tasks. For many users, especially those on mid-range systems, this alone can deliver a noticeable FPS improvement, sometimes in the range of 5 to 15 extra frames, depending on how many background processes were competing for resources. One important thing to keep in mind, game mode works best when you're running your game in full screen or exclusive full screen mode. Windowed or borderless windowed modes may not receive the same level of prioritization. We will talk more about this in another setting later. If you have never checked whether game mode is on, stop right now and turn it on. It takes 10 seconds and it costs you nothing. Setting 2. Disable hardware accelerated GPU scheduling, HAGs, or enable it, depending on your GPU. This one is a little more nuanced, but it is extremely important. Hardware accelerated GPU scheduling, commonly known as HAGs, is a feature in Windows 10 and 11 that was introduced to help reduce latency by allowing the GPU to manage its own memory more efficiently. On paper, this sounds great. In practice, whether it helps or hurts depends heavily on your specific GPU. Here's the rule of thumb. If you have an NVIDIA RTX 30 series or newer GPU or an AMD RX 6000 series or newer, HAGs can provide a genuine performance uplift. In these cases, enable it. If you are running an older GPU, anything from the GTX 10 series, GTX 16 series, or early RTX 20 series, HAGs may actually cause stuttering and frame time inconsistency, which means your FPS might stay the same on paper, but the experience will feel choppier and worse. In those cases, you want it disabled. To access this setting, go to Windows Settings, then System, then Display, then Graphics Settings. You will see the option for hardware accelerated GPU scheduling there. Toggle it based on your GPU generation. After changing this setting, you need to restart your PC for the change to take effect. Do not skip the restart. The setting does not fully apply until after a reboot. The reason this setting matters so much is that GPU scheduling directly impacts how frames are rendered and delivered to your monitor. Even a small improvement in scheduling efficiency can translate to meaningful gains in both raw FPS and frame time consistency, which is the smoothness you actually feel while playing. Setting 3. Set your power plan to high performance. This is one of the most commonly overlooked settings, and it is absolutely killing the performance of millions of gaming PCs right now. By default, Windows sets your power plan to balanced. The balanced power plan is designed to conserve energy by dynamically scaling your CPU clock speed up and down based on demand. This is great for laptops trying to save battery and for office work, where you do not need constant maximum performance. For gaming, it is a disaster. When your CPU is operating on the balanced power plan and a sudden burst of processing demand hits, like an explosion going off in your game, or a crowded multiplayer lobby loading in, the CPU has to ramp up from a lower clock speed to a higher one. This ramping takes time. During that time, frames drop. You experience stuttering. This is entirely avoidable. To fix this, press the Windows key, search for Power Plan, and open Choose a Power Plan. Select High Performance. If you do not see it, click Show Additional Plans. For desktop users, this is a zero downside change. Your PC is plugged into the wall. There's no battery to protect. For laptop gamers, high performance will consume more battery, so keep that in mind when gaming unplugged. But if you are plugged in, always use high performance while gaming. There's also an ultimate performance power plan that Microsoft designed for workstations. You can unlock this by opening Command Prompt as administrator and typing. This removes even the slight power management overhead of the regular high performance plan and can provide another small but real performance bump on some systems. Setting 4. Update your GPU drivers, then know when to stop. Updating your graphics card drivers are the communication layer between your game and your GPU hardware. Outdated or poorly optimized drivers can severely limit your performance and introduce bugs, stuttering, and crashes. Updating your GPU drivers is straightforward. For NVIDIA users, open GeForce Experience and click Drivers at the top. For AMD users, open AMD Software, Adrenaline Edition, and check the Driver tab. Always download the latest WHQL, Windows Hardware Quality Labs, certified driver, which is the stable release version. But here's the nuance that most people miss. Newer is not always better. Driver releases sometimes introduce new bugs or performance regressions for specific games. If you update a driver and notice your performance gets worse, or you start experiencing new issues, do a clean reinstall of a previous driver version. For NVIDIA users, use Display Driver Uninstaller, DDU, when switching drivers. Boot into safe mode, run DDU to completely remove the old driver, then install the version you want. A clean install eliminates corrupted driver files that can cause all kinds of invisible performance issues. A good habit is to check forums and communities for your specific GPU and the games you play before updating to a brand new driver release. If other users are reporting issues with a particular driver, wait a week or two for NVIDIA or AMD to release a hotfix. Keeping your drivers properly maintained, not just blindly updated, can be the difference between getting the FPS your hardware is capable of and leaving significant performance on the table. Setting 5. Disable Windows visual effects and animations. Windows is full of pretty visual effects. Transparency, animated window transitions, drop shadows, smooth scroll effects. These look nice on a desktop. They also consume CPU and GPU resources that your game desperately needs. Disabling these effects is one of the fastest and most impactful things you can do for gaming performance, especially on systems with integrated graphics or lower-end dedicated GPUs. Here's how to do it. Right-click on this PC and select Properties. Then click Advanced System Settings on the left panel. Under the Performance section, click Settings. You will see a window with a list of visual effects options. Select Adjust for Best Performance to disable all of them, or manually uncheck the ones you want to remove. The most important ones to disable are Animate windows when minimizing and maximizing, animations in the taskbar, fade or slide menus into view, fade or slide tooltips into view, and show shadows under mouse pointer. Some users prefer to keep a few visual effects for aesthetics. That is fine. The key targets for gaming performance are anything animation related and shadow related. Additionally, if you are on Windows 11, you can go to Settings, Accessibility, Visual Effects, and toggle off Animation Effects and Transparency Effects. Windows 11 has a transparency effect on the Start menu and taskbar that actually uses GPU resources. Disabling it frees up a small but real amount of GPU bandwidth that your game can use instead. These changes together can deliver a noticeable improvement in frame rate consistency, particularly the reduction in frame time spikes that cause that annoying stuttering sensation even when your average FPS looks acceptable. Setting 6. Optimize in-game graphics. Settings. The right way. Most guides tell you to just lower your settings and call it a day. That is lazy advice. The truth is that not all graphics settings are created equal. Some have enormous performance costs, others look great and cost almost nothing. Knowing the difference lets you get a better looking game at higher FPS simultaneously. Here are the settings that have the biggest performance impact and should be addressed first. Resolution scale or dynamic resolution. This is the most impactful setting in any game. Rendering at 1080p versus 1440p is the difference between millions of pixels being processed every frame. If you are playing at 1440p or 4K, try enabling DLSS, FSR, or XeSS, depending on your GPU. These AI-based upscaling technologies let you render at a lower resolution internally and upscale to your monitor's native resolution with minimal visual quality loss, but enormous FPS gains. DLSS quality mode on a 1440p monitor, for example, renders internally at about 900p. The difference is nearly invisible, and the FPS gain can be 30 to 60%. Shadow quality. Shadows are among the most expensive rendering operations in modern games. Dropping shadows from ultra to high or even medium can deliver 10 to 20 FPS on many systems with minimal visible difference in actual gameplay. Ambient occlusion. This is the subtle darkening effect in corners and crevices of 3D environments. It looks good, but it is expensive. Setting it to SSAO or turning it off entirely can free up meaningful GPU resources. Volumetric fog and lighting. These atmospheric effects are beautiful, but performance heavy. Turn them to medium or low. Anti-aliasing. If you are using DLSS, FSR, or TAA, you generally do not need additional MSAA on top of it. Stacking anti-aliasing methods is a performance killer. Pick one method and disable the others. The settings to keep high because they cost very little include texture quality and texture filtering. Modern GPUs have dedicated VRAM and texture units. Rendering high-quality textures has a minimal performance cost but a massive visual quality impact. Setting 7, enable XMP Expo for your RAM. Here's a setting that is hiding in your BIOS and that a surprising number of gamers have never heard of. And it can make a meaningful difference in gaming performance. When you install RAM in your PC, the system defaults to running it at a conservative baseline speed, often 2133 MHz or 2400 MHz, regardless of what your RAM is rated for. Your 3200 MHz or 3600 MHz RAM kit might be running at 2133 MHz right now without you knowing it. XMP, Intel, or Expo, AMD, are profiles built into your RAM modules that tell your motherboard exactly how to run that memory at its rated speed with the correct timings and voltage. Enabling XMP or Expo in your BIOS takes about 60 seconds and can significantly improve gaming performance, particularly in CPU-bound scenarios. To enable it, restart your PC and enter the BIOS, usually by pressing Del F2 or F12 during startup. Check your motherboard's manual. Look for an option called XMP, DOCP, or Expo in the memory settings. Select the profile that matches your RAM's rated speed and save. The performance difference varies by game, but CPU-intensive titles, competitive shooters, strategy games, open-world games with lots of streaming, can see 10 to 20% FPS improvements from RAM running at its correct speed versus the default underclocked speed. This is one of the most impactful free performance unlocks available to anyone with a modern PC. If your system is already stable at its current speeds and you enable XMP and experience crashes or boot failures, your RAM may not be fully compatible with your motherboard at that speed, or your specific modules may need slightly relaxed timings. Most modern DDR4 and DDR5 systems handle XMP without any issues. Setting 8. Close background applications and disable startup programs. Your PC has a finite amount of CPU, RAM, and GPU resources. Every application running in the background while you game is stealing a share of those resources. The fix is straightforward but surprisingly impactful. Open Task Manager by pressing Ctrl+Shift+SC. Go to the Processes tab and look at what is running. You will almost certainly find things you do not need. Browser windows with dozens of tabs open, Discord, Spotify, Cloud Sync applications like OneDrive or Google Drive, actively syncing, antivirus scans, background update processes. Any of these eating CPU or RAM while you game is directly reducing your in-game performance. Before launching your game, close everything that is not necessary. Keep Discord if you need it for voice chat. Close the browser. Pause Cloud Sync. Close any game launchers for platforms you're not actively using. The even better fix is to prevent these applications from starting at all. Go to Task Manager and click the Startup Apps tab in Windows 11 or Startup tab in Windows 10. You will see a list of every application that launches automatically when Windows boots. Disable everything that is not critical. Common offenders include Steam, Epic Games Launcher, Discord, Spotify, OneDrive, Teams, and various vendor-specific apps like RGB lighting software and system monitoring tools. Disabling startup programs does not remove them. You can still open them manually whenever you need them. It just stops them from loading resources in the background when all you want to do is game. Many users report freeing up 500 nLP to 2 GB of RAM just by cleaning up startup programs, and that freed RAM goes directly into your game's performance budget. Setting 9. Set your game to run in exclusive full screen mode. This is a setting that causes more confusion than almost anything else in PC gaming, and getting it right can have a significant impact on your performance. There are 3 display modes available in most games: exclusive full screen, borderless windowed, and windowed. Many players default to borderless windowed because it makes alt-tabbing faster and smoother. What most people do not know is that borderless windowed comes with a hidden performance cost. In borderless windowed mode, your game does not have exclusive access to the GPU output. Windows Desktop Window Manager, DWM, is still compositing your display, which introduces an additional processing step and can add latency and reduce FPS. In exclusive full screen mode, your game takes complete control of the display output. The GPU renders directly to the screen without going through DWM. This reduces input latency, can improve frame rates, and enables features like NVIDIA G-Sync or AMD FreeSync to work in their most effective modes. The trade-off is that Alt-tabbing becomes slower. The game has to release control of the display before Windows can show the desktop. For most gamers who are focused on performance, this is a worthwhile trade. To find the setting, look in your game's video or display options. It is often labeled as display mode, window mode, or screen mode. Select full screen or exclusive full screen. Note that on Windows 11, Microsoft made some changes to how DWM works that reduced, but did not eliminate, the performance gap between exclusive full screen and borderless windowed. However, for competitive gaming where every frame and millisecond of latency matters, exclusive full screen remains the better choice. Setting 10, configure NVIDIA or AMD control panel settings for maximum performance. Your GPU's control panel is one of the most powerful tools available to you for FPS optimization, and most gamers have never opened it. For NVIDIA GPU users, right-click your desktop and open the NVIDIA control panel. Go to Manage 3D Settings. Here you will find a long list of options. The key settings to change for maximum gaming performance are as follows. Set Power Management Mode to Prefer Maximum Performance. This prevents your GPU from downclocking when it senses reduced load, which can cause stuttering during transitional moments in games. Set Texture Filtering Quality to High Performance. Set Threaded Optimization to On. Set Vertical Sync to Off here. You will manage VSync inside the game itself or through G-Sync if you have a compatible monitor. Set Low Latency Mode to Ultra for competitive games where responsiveness matters most. You can apply these settings globally or on a per-game basis. Setting them globally gives you the performance benefit across all games automatically. For AMD GPU users, open AMD Software, Adrenaline Edition. Go to the Gaming tab and then Global Graphics. Set Radeon Anti-Lag to Enabled. This reduces input lag similarly to NVIDIA's low latency mode. Set Radeon Boost to Enabled. If you play fast-paced games, it dynamically reduces render resolution during fast motion, where the difference is least visible. Set Image Sharpening to a moderate level if you use resolution scaling, as it helps recover perceived sharpness. Set Wait for Vertical Refresh to Off unless application specifies. These control panel optimizations work in concert with everything else we have covered today. Alone, each setting provides marginal gains. Combined, they represent a comprehensive optimization of your entire gaming pipeline, from how Windows allocates resources to how your GPU renders and delivers frames to your monitor. The cumulative effect across all 10 settings is often dramatic. Here is the thing about PC gaming performance. Your hardware sets the ceiling, but your settings determine where you actually operate within that ceiling. Most gaming PCs are running significantly below their potential, not because of weak hardware, but because of a combination of suboptimal settings, background resource drain, and default configurations that were designed for general use rather than gaming performance. Going through all 10 of these settings takes less than an hour. What you get in return is a gaming experience that is smoother, more responsive, more stable, and often significantly higher in frame rate. For competitive players, these improvements translate directly into better reaction times and more consistent performance under pressure. For everyone else, it simply means games that feel the way they are supposed to feel. Start with the power plan and game mode. Those are 5-minute fixes with immediate results. Then, work your way through the GPU drivers, BIOS settings, and control panel optimizations. Do them one at a time and launch your game between changes so you can see and feel the difference each one makes. Your PC is already capable of better performance than you are currently getting. These 10 settings are how you unlock it. Go make the changes, drop into your next session, and feel the difference for yourself. Your FPS and your gameplay will thank you.